The 80% rule is the standard for checking if adverse impact exists. However, it doesn't tell us whether that difference is real or if it could have happened by chance. That's why industrial organizational psychologists also use statistical significance tests like chi-square or Fisher's exact. Both tests help us answer the big question, which is, are these differences real or just random? If the result crosses a certain threshold, we say it's statistically significant. In other words, we're confident the difference is real and not just a fluke. When adverse impact is detected, it is important to dive a little deeper to understand why it has occurred. For example, take a look at the cover page on the screen. In this dataset, adverse impact was flagged for the gender and ethnicity columns. Depending on the characteristics of your data, the software will choose the appropriate statistical significance test. In this specific example, the Fisher's exact test was administered. When the 80% rule was violated for the gender and ethnicity columns, the Fisher's exact test was then administered to determine if this violation happened by coincidence or if the results are statistically significant. The green check mark in the gender column indicates that the 80% violation may have been skewed due to small sample sizes. In the ethnicity column, the red X tells us that the difference in selection rates between ethnic groups is statistically significant, meaning it is unlikely to be due to chance and may reflect a real imbalance. Chi-square and Fisher's exact tests help move beyond the simple 80% rule to answer a key question. Are the differences in hiring rates likely due to chance, or do they suggest a real imbalance between groups? By pairing these tests with the 80% rule, you can give decision makers a clearer, more defensible picture of where there may be fairness concerns in your selection process.